Welcome back, my friends, to my channel, and it's been quite a while since I uploaded a video, and in the last few months I had a lot of procrastination to do, and you know what they say, when you procrastinate, at least procrastinate with something productive. In my case, that was learning COBOL to distract myself from doing the things that I should have been doing. And this is how my little COBOL programming course came to be, even though it doesn't really have anything to do with cybersecurity. But perhaps, just like me, you might be interested in learning COBOL just for the shits and giggles. There's not that much to do with this language, but it's, for me, pretty much like tinkering with an old-timer car. You have this fascinating old language that is just really, really weird and so different from modern day languages that it's just fascinating to play around with it. Now, in this introduction video, I want to tell you a little bit about the background of the COBOL programming language and, of course, show you a first working example of a COBOL program. Now, what will I do here? The first part is what is COBOL, so I'll tell you a little bit about the history and the intention behind COBOL. Then I will introduce the GnuCOBOL compiler, which I will be using for this course, and then I will show you a first COBOL program. What is COBOL? It's, as I said, a very old programming language. It was developed in 1959, and the idea was to use it specifically for business applications. That's reflected in the name. COBOL is short for Common Business-Oriented Language. And together with the functional programming language Lisp, which is very different from COBOL, and the numerics-oriented language Fortran, it is one of the first structured programming languages ever developed. It was developed by a committee that was made up of individuals from the industry and the US government. This committee was called CODASYL, so the Conference on Data System Languages. And the first language standard, COBOL 60, was published in 1960. And the idea behind the design of the language COBOL was to make it as close as possible to written English, because it was supposed to be used in business applications, and the idea was that even non-programmers should be able to read it and understand what the program does. Now, in its original form, it was a very limited language, and originally it did not provide any methods for modularization. You could not hand over parameters to procedures, so just use global variables instead. And if you wanted to branch, you had to use goto. And so the programs written in the old COBOL dialects were very monolithic and convoluted pieces of code. In fact, programming COBOL kind of reminds you of having a very verbose assembler, which has some very oddly powerful methods in it. So initially, COBOL was very widely adopted, so apparently the idea of having a business-focused language was very appealing. And by the 1970s, it became the most widely used programming language. Now, its strength, which made it attractive, and of course that was also due to the lack of alternatives, was that it was really good at batch processing of data records. So basically reading data records of a certain structure from a file, processing it, writing it back out to a file, and doing that with huge amounts of records from the same data type. What you wouldn't use it for is high performance computing, web server, something like that. That is really not something COBOL was made for, and even today is not really good to do with COBOL. Now, as I hinted at before, the COBOL language had to be adapted and extended because the original COBOL was so limited. So over time, several new standards were devised, and the most important ones of these were from the years 74 and 85, so especially COBOL 85 from 1985. And then IBM had its own language standards throughout the years. So with these newer standards, more common features of programming languages were introduced. So COBOL was modernized to some extent, but still to this day retains its archaic charm. And still some things are rather difficult to code in COBOL that are, I would say, easily doable in almost every other modern programming language. And yeah, IBM had its own COBOL standards, so this was due to the fact that IBM was an early adopter of COBOL, and given that IBM adopted COBOL, it's reasonable to assume that this also pushed the popularity of the language for quite some time. And even today, COBOL is still used on IBM's mainframe operating system, z/OS, or on the other mainframe operating systems as well. So yeah, the IBM mainframes are one of the most important areas of applications for COBOL even today. Then there's another company called Micro Focus that heavily developed COBOL from the late 1970s onward, and even to this day it provides one of the most common COBOL compilers, and it offers a lot of services focused around integrating COBOL code with Java and .NET applications. So basically, that's a lot of the service that is done for COBOL these days, to integrate legacy COBOL code with modern day Java or .NET applications, which are probably the main platforms for business programming nowadays. What is a little bit problematic is that COBOL vendors often implemented their own language features that were not part of the standard, and this can lead to quite some obscene incompatibilities between different compilers by different manufacturers. Now, eventually, COBOL's relevance began to wane with the advent of modern programming language. So today there's almost no new software written in COBOL, perhaps, as I said before, with the notable exceptions of IBM mainframes. But at least once the programming language C arrived at the scene, which was a general purpose programming language, the expectation of what a programming language should offer feature-wise and should be able to do rose to a level that COBOL could not meet. So C certainly is a much better programming language than COBOL. Now, the newer language standards that were introduced and introduced additional programming language features could remedy some of these shortcomings of COBOL, but it became ever more serious once object-oriented techniques became widely popular by the 1990s, and nowadays object-oriented programming is standard. And so, the domain of business applications eventually fell to other languages, as I said before, Java and .NET, or C# being the language incarnation of .NET. Those are the ones that took over a lot of the business application space. Or alternatively, there are off-the-shelf systems such as the ones offered by SAP. And it's perhaps ironic that SAP has its ABAP programming language, which is probably the only programming language ever inspired by COBOL. And ABAP is a pretty painful programming language itself. So it was developed in 1984, and you might really wonder what was going through their heads when they basically copied COBOL, or the ideas, the structure of COBOL, even though by then much more versatile programming languages like C were already known and available. And I would say it's safe to assume that from the 1990s and onwards, only very little new software was written in COBOL outside of IBM. So the main purpose of COBOL programming since then was basically to integrate existing COBOL code with new code. But if you actually know some major programming projects or software projects from the 90s or later that were written in COBOL, then please leave a comment. I would actually be very interested to know about these things. And what is maybe a bit surprising, there were 2 modern language standards released, one in 2002 and one as late as 2014. And these standards introduced object-oriented features to COBOL and also changed the decimal arithmetic in COBOL from fixed point to floating point. So the idea is, of course, to make COBOL much more compatible with modern day programming languages. Today, COBOL may be forgotten, but it's definitely not gone. There is a huge legacy code base in business and in public service applications. I would speculate that it's much bigger in the US than in Europe, but I might be wrong. Simply for the reason that I think in the US they might have adopted software for data processing earlier than they did in Europe. And at the time when they adopted it, it was probably written in COBOL. Whereas when Europe started a wide adoption of business and public service applications, there might have been other programming languages available already. Even though banks and insurances in Europe still use COBOL a lot. There are estimates that say that around 2/3 of all source code in the world is COBOL. But it's a bit hard to verify this. So I looked into it a little bit and tried to see where these numbers came from. So there's apparently a single survey by an outfit called DataPro that was conducted in 1997. And it was conducted among a limited number of mainframe users. So that might have been a very skewed estimate that they found, because obviously COBOL is much more prevalent on mainframes than on other computers. But nevertheless, even more recent surveys found that there is a lot of COBOL code out there and there is a great demand to keep it running. The reason being that given that COBOL is still in use today, it means it has stood the test of time and it is considered to be very reliable. So operators are very reluctant to replace it because it works, and the main difficulty is not the way it works, but how to integrate it with new software. So, as I said before, that's probably the reason why the modern COBOL standards were introduced, and to make COBOL more compatible with modern languages. As I said before, the motivation behind COBOL was to provide a programming language that could be read for people without a technical background, so business people, accountants, whatever, who would use the software and maybe have to change it on their own if their use case changes. And to achieve this, it was designed to resemble natural human language, that is written English, and so that it also would be self-documenting in this way. So you would not have to write long comments but just look at the code and understand what it's supposed to do. So the program instructions are written in the form of sentences, of course, very simplified sentences, and are ended with a period. And even arithmetic instructions can be spelled out in words, which, well, personally I find absolutely appalling, but you can do it. Like instead of using a plus sign, you can write add. Instead of using a multiplication symbol, you can write multiply, and so on. It's pretty awkward, but COBOL also allows you to use normal mathematical symbols, so it's not that bad. Naturally, these aims made COBOL a very verbose language and gave it a very convoluted syntax. So writing COBOL compilers is apparently one of the most difficult tasks for compiler engineers to do because of this very convoluted language structure. I think it's fair to say that it's absolutely not accessible to non-programmers, and maybe even harder to learn than many modern languages. That's of course always a bit of a matter of taste, so yeah, that's just my careful assessment. Now, you have to understand that at the time that COBOL was designed, you didn't really have much to compare it with, and you also couldn't really predict in which direction programming languages would evolve. So the idea of having a programming language, particularly for business application, was not such a bad idea back then. But as time showed, the emphasis for this language was probably on the wrong aspects. But again, this was probably very difficult to predict back in 1959. Now, let's have a look at the GnuCOBOL compiler that I will be using for these videos. So there are a few COBOL compilers available. There's the IBM Enterprise COBOL, there's Micro Focus Visual COBOL, Fujitsu Net COBOL, and GnuCOBOL. And the only one freely available out of these is GnuCOBOL, so you can just download it on the internet. Even though IBM and Micro Focus allow you to download the test version and use it for a limited amount of time, but you have to register for that and all, so it seemed more convenient for me to just go with a freely available open source COBOL version. So that's why I will use GnuCOBOL here, but I will use it with the IBM language standard. So GnuCOBOL allows you to use different COBOL dialects, and the compiler can handle them all. So yeah, I decided to go with the IBM standard because I think it's a very widely used one and probably has the most relevance for the real world applications. Here's the address where you can download the GnuCOBOL compiler. It's https://gnucobol.sourceforge.io. And it has a very extensive documentation. So if you have some patience, that's actually pretty good learning material. So it has a programmer's guide, a language specification, sample programs, and a document how to integrate GnuCOBOL with C code. The GnuCOBOL compiler is closely linked to the GNU C compiler, the GCC, that you probably have heard of. And yeah, it's probably more correct to actually talk of a transpiler because GnuCOBOL doesn't compile it directly into binary code, but it actually produces C code, and then this C code is compiled into binary by GCC or whatever your standard C compiler on your system is. And a nice feature of this is that it's actually rather easy to link COBOL programs and C programs together with GnuCOBOL. So it's very similar to doing it with GCC. And as I've discovered, if you use the Unix version of GnuCOBOL, you can call practically any function from the C standard library or the POSIX libraries from COBOL without any additional effort. So you don't have to include any libraries or header files or something like that. You can just call them. It is a bit difficult to fix the parameters for C function calls from COBOL because of the very different representation of data that these two languages have, but I will get to that in a later video. And as I mentioned before, GnuCOBOL supports many different COBOL standards like COBOL 74, 85, the IBM standard, or Microfocus. And GnuCOBOL even defines its own COBOL dialect, so the default standard. But I will not use GnuCOBOL's own dialect because it's highly incompatible with the existing standards, even though it adds a lot of new features and does away with a lot of archaic restrictions. But I think it's more interesting to actually stick with the language standard that is widely used. So that, again, for me is the IBM standard. You can download the source code of GnuCOBOL at the same internet address where you download the compiler, so at SourceForge. It can be quite interesting to look at the source code and see how the C code looks that's generated from the transpiler. So you basically have a COBOL runtime that is coded in C, and if you want to combine C code and COBOL code, it's good to look at the source code to understand how GnuCOBOL actually handles the data types from COBOL internally. Now, you can, if you have Linux, you can often use a package manager to just install GnuCOBOL, so you wouldn't have to download and compile it yourself. I'm using macOS, so here it's highly recommended to use Homebrew to install GnuCOBOL. So you can install Homebrew, which you get at brew.sh, and then you can get the formula, so the package information for GnuCOBOL at this address here. And then it tells you how to install GnuCOBOL on a Mac using Homebrew. You can also install it on Windows, but I cannot give you any details on that as I haven't done it, but I think it should probably not be too difficult. Once you have installed GnuCOBOL and you have some program available, let's call it program.cob, then you can compile it as follows. You use cobc for COBOL compiler or COBOL2C, I'm not sure. -x minus std standard equal to IBM, and then the source file program.cob. So here the -x option indicates that we want to produce an executable file, and the name of that file will be the name of the input program with the .cob removed. If we would leave out this -x, then the compiler would actually build a dynamically loadable module, so a library, if you like. And this parameter here specifies that we want to use the IBM language standard. So alternatively, you could use something like COBOL 85 or Visual COBOL or something like that, and then compile this program after different language standards. If you leave it out, it would use the default standard, which is GnuCOBOL's own language. You can replace the -x by a -C, and in that case you would actually get the intermediate C code that GnuCOBOL produces. So that's also very interesting to see how the COBOL code gets translated into C code. And in this case you get 3 output files, namely program.c, so which is just the corresponding C program for your COBOL program. You get program.c.h and program.c.l.h, which contains the functions in program.c, and then the global and local variables for your program in these 2 header files respectively, obviously the L indicating local. So it's a bit bit much. You have 3 files and all your data is distributed over these files, but if you want to do some research on how the transpiler works, maybe it's good to have it separated like that. Yes, and there are of course many other options, but for us, the ones we see here should be enough for now. Well, let's look at a first COBOL program. If you actually look at some real-world COBOL code, then you might wonder if it's a language requirement to type the source code with caps lock on, because very often the whole code is just written in capital letters. And there's a reason for that, and this is that originally COBOL programs were literally punched into paper punch cards, and the encoding used for these punch cards only allowed uppercase letters. That's why very often COBOL programs are all in uppercase letters. It's not a strict requirement to write everything in all uppercase, and I will mix upper and lowercase letters here, but you will still find a lot of COBOL programs in all uppercase. Now my convention will be that following the custom COBOL keywords and divisions and sections, we'll learn later what these are, will all be written in uppercase, but not following the conventions, I will write variables in lowercase, and multiple words in a variable name will be separated by hyphens. So that's a neat thing that COBOL actually allows you to do that. And here is our first COBOL program. It is not the simplest program you could think of. I've made it a little bit more complicated than necessary to show you a little bit more. And yeah, we will see in the coming lectures what these parts here actually mean. Just very quickly, let me tell you, this is the identification division. So this contains some information about the program, mainly the program ID. So this is a name with which other programs can actually address your COBOL program. And then there's some fluff about the author, the date written, and so on. Data division is the part where you define your variables. So here, working storage section is a section within the data division. And here I define a variable called greeting with this somewhat strange picture clause. So this is a COBOL keyword used to declare the type of a variable. I don't know why they call it picture or pic for short. And x20 here just means that it's an alphanumeric type, so basically a string that is 20 characters long, or up to 20 characters long. Then there's the procedure division, which is the part that contains the actual program logic. What I do here, I move the string hello world into my variable greeting, which is not longer than 20 characters, so it fits in there. And then I use the built-in display function of COBOL to display greeting. So I should see hello world as an output. And then stop run ends my COBOL program. And I will test this with copc -x, standard equal to IBM, hello.cop, and then call the hello, and I expect to see hello world. So let's switch to an editor and type this program and then compile it and run it. So here I am in Xcode with hello.cop. You can see some lines here that structure the visual layout of the COBOL program, and I will explain in more detail how that works in the next video. In Visual Studio there's actually quite a nice extension and a plugin called COBOL by Bitlang, and this works pretty well. There is an extension that is particularly made for GnuCOBOL, but I would not recommend using that because for me it behaved really weirdly. So just the ordinary COBOL extension in Visual Studio works pretty well. So let's start with the COBOL program, the identification division, program ID, world. The author, that's me. That would be it. Hackflix. Date written. Well, by now it's July 2023. We insert a comment line here just to visually separate the identification division from the data division and the procedure division. The data division contains the so-called working storage section, which is used to define the actual variables. Said before, here we have our variable called greeting, which is a string, an alphanumeric string indicated by this x, and 20 is its length. What this number here means, that I will explain that in a later video. It's basically a way to structure your data types. Now comes the procedure division, and this is where we actually want to output the hello world. And it's customary to start the actual code in one tab behind the division header. I have this here. I move hello world, the string hello world, to the variable greeting. Then I want to display it on the terminal. And I could have written display just hello world here and not used the variable greeting, but I wanted to make the program a bit more interesting. That's why I introduced this variable. Okay, so this is our hello.cob. And now let's compile it. copc -x to produce an executable file. Standard will be set to IBM. And hello.cob is our source file. Now I get a linker warning here that we can just ignore that. That is just something particular to my macOS. The compilation worked anyway. And we will test it. And there it is. Hello world. So our COBOL program works. And with that, we are at the end of this introductory video on COBOL. And in the next video, I will explain how the structure of a COBOL program looks. Thank you very much and see you soon.